This video is all about the coordinate geometry of parallel and perpendicular lines, in particular the gradients of those lines. In the first diagram there, the blue line and the green line are both parallel. Let's work out the gradient of the blue line by doing the change in the y divided by the change in the x. So I've just chosen 2 points that I can read off the graph easily there. The change in the y is 2, the change in the x is 1, so 2 divided by 1 is 2. The gradient of the blue line is 2. Let's do the same thing with the second line, the green line. So again, pick 2 points that we can read off easily. The change in the y is 2, when the change in the x is 1. And so you can see that the gradients of those lines are the same. They have the same steepness, they're going in the same direction, they are parallel. Right, let's look at the second diagram. The blue line is exactly the same as it was for the first diagram. The gradient is 2. The red line, let's pick 2 points that we can read off easily for the red line. So I'm going to pick this point here and this point here. When I go across 2, I go down 1. So the change in the y is -1. The change in the x is 2. So the gradient is -1/2. So when we have perpendicular lines, you will have remembered this from GCSE as being the negative reciprocal. What this means is the gradient of my first line was 2/1. If I did the reciprocal of that, so flips it upside down, so 2/1 becomes 1/2, and it's the negative reciprocal, so -1/2. There is a more formal way of saying that though. Notice that if I multiply those two gradients together, the 2 and the -1/2, I get -1. And that's always going to be the case when you have perpendicular lines. If you multiply the two gradients and get -1, the lines are perpendicular. So let's summarise those results in this table here. Parallel lines have the same gradient. Perpendicular lines have the negative reciprocal gradient. When you multiply the two gradients together, you will get -1. Right, let's have a look at a few examples using that fact. We're going to do 4 examples, starting off with a couple of relatively simple ones. Example 1, we need to find the equation of the line that's parallel to y equals 3x minus 4, passing through the point 2, 11. So parallel means same gradient. Now the gradient of the line we've been given is 3. Remember, y equals mx plus c. So the gradient of that line is 3. Which means the line that I want will also have a gradient of 3. So it will be y equals 3x plus something. I don't know where the line is going to pass through on the y-intercept. All I know so far is that its gradient is 3. But I do know that the x-coordinate, when the x-coordinate is 2, the y-coordinate is 11. So if I substitute those points in, I can find out that c has to be 5. So the equation of the parallel line that passes through the points 2, 11 is y equals 3x plus 5. Second example, find the equation of the line that is perpendicular. So we're thinking negative reciprocal. To 4y plus x equals 12, passing through the point -17. So I want to do negative reciprocal of the gradient of this line. However, the way that that's written, as in it's not currently in the form y equals mx plus c, makes it tricky for me. So first thing I'm going to do is I'm going to rearrange this equation by subtracting the x from both sides. And then I'm going to divide both sides by 4. So the minus 1x divided by 4 is minus a quarter x. The 12 divided by 4 is 3. Now that I've rewritten that line, I can see that the gradient of the line is minus 1/4. Which means that the gradient of the perpendicular line will be the negative reciprocal of that. So it's going to turn into a positive, and it would be 4/1 or just 4. The gradient of the perpendicular line is 4. So I can now say y equals 4x plus c. And I know that when x is -1, y is 7, so 7 equals -4 plus c, and the y-intercept has to be 11. Therefore, the equation of the perpendicular line passing through the point -17 is y equals 4x plus 11. Third example. We've been given 3 coordinates A, B and C, and we're told that they form a triangle. We need to prove that this is a right-angled triangle. Now, just to help me explain this, I'm just going to draw a little sketch just to help. With coordinate geometry questions, often they can seem quite difficult to begin with, but once you've drawn a sketch and you can visualise what's happening, it becomes easier. So the point A is 2, 3, which is roughly here. The point B is 6, 6, which is up here somewhere. And the point C is 5 minus 1, which is roughly here. And these points form a triangle. And I need to show that this is a right-angled triangle. So if it's a right-angled triangle, then 2 of these lines are going to be perpendicular. Either the right angle is going to be here, which I think it is, by the way I've drawn it. I might have drawn it wrong and that's the right angle, and that's the right, or that's the right angle there, but probably not. I'm going to check this one here first. So to prove that that's a right angle, I want to work out the gradient of this blue line and then the gradient of this green line, and hopefully show they're perpendicular. So the gradient of the blue line, I'll call it M1. Change in y divided by the change in the x. So change in the y, 3 minus -1, divide by the change in the x, 2, take away 5. So I get 4/-3 or -4 thirds. Right, gradient of the green line. Change in the y, so 6 minus 3. Divide by the change in the x, 6 minus 2, is 3/4. Now, by looking at those two, you can probably say that they are perpendicular because of the negative reciprocal. But better than that, I'm going to be more formal. I'm going to say M1 times m2 equals, so m1 is the minus 4 over 3, m2 is the 3 over 4, and note that when we multiply those together, the 3's would cancel out, the 4's would cancel out, and we just get minus 1. Therefore, they are perpendicular, and it is a right-angled triangle. This is not the only way of doing this question. Alternatively, what I could have done is I could have worked out the length of this line here by doing the change in the x coordinate squared plus the change in the y coordinate squared, square rooted. Then I could have worked out the length of this line here with the same method. Then I could have worked out the length of this line with the same method. Once I'd worked out the lengths of each of those lines, I could have done a bit of Pythagoras. A squared plus b squared equals c squared. But I'm sure you can agree that is longer than looking at the gradients. Last example for this video. Line L1 has the equation 3x plus y equals 6. Line L2 has the equation 2x minus 3y minus 15 equals 0. Part A says determine whether the lines are parallel, perpendicular, or neither. So I need to see, are the gradients the same? Do they multiply to make minus 1? Or neither? So let me rearrange each of these so they're both in the form y equals mx plus c. So the first line, I'm going to subtract 3x from both sides. So I'd get y equals minus 3x plus 6. So its gradient is minus 3. The second line, let me add the 3y to both sides. And then divide both sides by 3. I get 2/3 x minus 5 is equal to y. So the gradient of the second line is 2/3. The gradients are not the same, so they're not parallel. If I were to multiply those two gradients together, I'd get minus 2. So they're not perpendicular. So therefore, these lines are neither parallel nor perpendicular. They're neither. And I just write a little sentence here saying gradients are not the same. Actually, to be even shorter, I'm going to say M1 is not equal to M2. M1 times M2 is not equal to minus 1. Therefore, they are not parallel or perpendicular. Therefore, neither. Right, part B of this question says that they intersect at point P. So I want to find where these equations intersect. So I want to, at the point they intersect, they're going to have the same x and y coordinates. So if I do simultaneous equations here, so if I substitute this in instead of the y over here, I would have the 2/3 x minus 5 equals minus 3x plus 6 times both sides by 3 to get rid of that awkward fraction. Add the 9x to both sides. And while I'm at it, I'm going to add 15 to both sides. So x is 3. Now I know x is 3, I can substitute that back into either of the original equations to work out what y is. So y is minus 3 times 3 plus 6, which is minus 3. So the coordinates of point P are 3, minus 3. Right, make sure you've got your notes copied down for this so far, because I'm just going to rub this out just so I've got a bit more space. Press pause if you need to. Right, part C, we're told that L1 intersects the x-axis at point A. So L1 is this line intersecting the x-axis. Now that means that y is 0. So if I substitute y being 0 in here, I would get 0 equals minus 3x plus 6, add 3x, divide both sides by 3. So the point A is 2, 0. Then part D of the question says that L2, which is this one, intersects the y-axis at point B. Now I know intersecting the y-axis is when x is 0. So if I substituted 0 in here, I get 2/3 times 0 minus 5, so minus 5. So point B is 0, minus 5. Right, for the last part of the question, I'm going to clear my screen again. So just again, press pause and make sure you've got all your notes copied down if you haven't yet. And we are asked to work out the area of triangle OPB. Now, this is another question. It's quite difficult to visualise the way it's been done so far with all of this text. So let me just draw a little triangle so I can try and figure out a little sketch so I can try and figure out what this triangle looks like. Point O is the origin, so that's this point here. Point B is this that we just found there, which is the coordinate 0, minus 5. And the point P was what we found in part B of the question, which is the coordinate 3, minus 3. So the x coordinate is 3, the y coordinate is minus 3. So this is the triangle OBP. And we know how to work out the area of a triangle. If we can, we're going to do half base times perpendicular height. If we can't do that, we could do half AB sine C. But in this case, we can do half the base times the perpendicular height, because the base of this triangle here, I know that that is just 5. And the perpendicular height of this triangle here is going to be the x coordinate of P. This is 3. So half of 5 times 3 is 15 over 2, or 7.5 units squared.